Perfect.
Thank you, Felix. Welcome. I would like to talk about the TOP project. It's a part of a consortium with TATASteel, Potilion and Convectis, where we try to find solutions for the future steelmaking, circular energy and energy efficiency. I'm Tom van der Velde, working as a senior energy consultant in TATASteel, and I do this project with my colleague Paul van Beurten, who is working at the R&D department. The top project is about the Torpedo Optimalization project. What I want to introduce to you is where is Tata Netherlands and what is a pig iron torpedo, why TATASteel is investing in digital twins and the vision towards 2050, how we gonna approach this project and the goal of the project and the timelines. Because we're going to look at a steel site in the Netherlands where the blast furnace, where the pig iron is made, will transport to the basic oxygen steel plant. And now I'm going to take you to the plant. What we see over here are the two blast furnaces where from coal and iron ore pig iron is made. The pig iron coming from the blast furnace is carried in a 300 kiloton torpedo, a vessel, cladded with refractory, pulled by a train to his next stop, and that's the basic oxygen steel plant. This plant will convert the pig iron into steel. In real life, this is the plant. These are the torpedoes emptying in the next vessel where it's put into a converter. Back to the project and the goal where TATASteel is aiming for the next 30 years. Because we will abandon the blast furnace and go for a hydrogen plant, making DRI, capturing all the carbon and CO2, and so make circular steel. Part of that is we have to introduce Industry 4.0, where the strategy of digitization by big data and improve our products and services is one of the building blocks. The project and the program is called FUSI and consists of the strategy becoming a circular and zero steel company connecting with Industry 4.0. So we defined 3 pillars of so. Taking the thermal management of the digital twin of the torpedo, looking at the refractory improvement, and use a lot of waste heat on a circular energy way. We defined 3 work packages. The refractory for the torpedo has to, and all other has to be in optimized shape. We have to store the waste heat coming from all those highly intensive energy processes, and we want to digitize and become a smart factory. On the last one, I will go into the thermal process management, where we want to develop a digital twin. So we want to apply this on a torpedo. So what we want to digitize is the hot metal route, going from the blast furnace into a torpedo and emptying the torpedo in the next chain, making in the converter steel out of it. With the goal of reducing pig iron losses up to 12 million a year. I'll come to that, or how that is calculated. Now a little bit of the technique behind that. We own finite-element methods of the torpedo. So what we did in the past, we make the calculations and make a computer model out of the torpedo. We validated how the temperature is emitted from this vessel and made that in a computer model. But that's not already a plant model. Now we have used a plant model with analog formulas, but we think with a digital twin we can improve that, going for a more real-time approach of this very time-consuming finite element method to a computer model, what is called a reduced order model, or an order model able to be computed in real time. Now what we use is a program where the torpedoes are scheduled to get with the existing analog formulas the highest temperature outcome. But we want to do that differently because we think if we play scenarios in this loop, we think we get a higher outcome because we have questions that still are able, that has to be answered. And that answering could be, what is the optimal number? How are the torpedoes filled? What is the right way to operate 20 of them? So we are made an outline for digital twin of every torpedo. I already said we have 20 of them. We make a reduced order model and we put some intelligence how the torpedo is in its life cycle. We take this as a single agent, which which the digital twin can predict what the temperature outcome is on its way. Then we put the digital twin, the single agent, in a multi-agent platform to go for the supply and demand. The supply from the blast furnace and the demand from the basic oxygen steel plant is known. So we have to transport 20,000 times a year that torpedo filled with pig iron and decide what is the best logistic order and do that on a prescriptive way so we find optimal output and reduce the temperature loss. Because we want to create with this platform a decision support system for the operator, going from the real-time data, looking at what happened and looking what is the diagnostics and go for predictive what we know and what will happen. So an operator can get a decision support to find the right way to make the logistics of the torpedoes in a right way and give the feedback for the data. So the loop is closed, splitting it to an analytic part and the operator human part. Now the value, because why do we want to make a decision support of? I already said, reducing temperature between the blast furnace and the oxygen steel plant will give iron losses. Research has found a connection between the temperature and the iron loss. So we aim, or we have a rule of thumb, that every degree of temperature loss will produce 0.6 kilograms of CO2 per ton crude steel. And so 1 degree temperature loss means 200 kilograms of CO2. With the digital twin, we aim for 5 to 10 degree temperature gain, so we can make more iron out of it, making that value of 12 million and reducing kilotons of CO2. How are we going to do that? Because we think there is more possible than only temperature. Because we would like to find, and that's more future developments, what is the ideal temperature in the torpedo, what is the number of ladles, and what is the chain effect if we connect two of those chains together. So, to summarize, we want to gain knowledge about this industrial digital twin design and of our FEM models, putting them into reduced order models. We want to learn the principles behind the artificial intelligence solution we want to take. Then we want to validate those ROMs, and first we have to develop an offline digital twin parallel to the existing process. Then we have to improve the opportunities regarding the thermal management of this production chain, and then we want to do it a real-time online digital twin. We approach this as follows. First we get the data, we make the architecture of the data, we improve it with our advanced analytics capabilities, we start making a minimum viable product and do the offline digital twin, and then implement it and go for a sustainable solution. Then we have to do that in 4 years. First starting with the minimal viable project, then go for the tool scale up, and then put it in the 3rd year to daily operation, and then transform it into a platform, let's say an ecosystem, and do that on an agile way. Any questions?
Wow, that's a really ambitious program that you have there, Tom.
Yeah.
Say, are you at the beginning of the project, or are you already a bit advanced?
No, we are in the beginning. We developed the reduced order model, so the engine of the digital twin is in place. And the next step is that we concentrate on the minimum viable project by doing a simulation offline.
Nice. Werner has a question.
Yeah, very nice presentation. And I have a question. Will you do this all by yourself, or do you need do you involve other companies as well?
We have made a consortium of a platform developer and a validation company. We are more doing the engine because that is our core business, making steel. So the core business is making a reduced order model.
Mm-hmm. Okay, so all the data wrangling and things are done by the partners in the consortium.
Yeah.
Okay, thanks.
And also, do you just consider the temperature as a quality indicator, or does the steel quality and other qualitative things also are they also involved?
Not yet. You're on the right track. We made some, let's say, more. The ROM is capable of doing also the quality, but we want to keep it simple, and temperature is one of the one indicators. But yeah, there are more. But that I didn't want to tell, because then the whole scale is coming by. So temperature is what we aim for, but I already made a proposal for the quality, but that's a little bit more complicated.
You also have to start small, get things to work, and then you can go from there.
True.
Yeah. Sebastian, is your hand just still up, or do you have another question?
I think it's still up. I wanted to put it down, but I think I missed the button.
No worries, no worries. Any other questions? All right then. Thank you, Tom,
Okay.
for the presentation. And what I really like about this project that it aligns so well with the timeline of the annex. I mean, there are going to be insights coming in right in a time for what we are trying to do here. So that's plain perfect. Thank you.